To everyone. I'm Karen Day, Dean of the Faculty of Science here at the University of Melbourne. It gives me great pleasure to welcome you to the Carlton Connect Initiative's 5th DICE lecture. Before introducing Daniel, I'd like to acknowledge the Wurundjeri people as traditional owners of this land and pay respects to the past and present elders of the Kulin Nations. You'll see the posters around here tonight of the Carlton Connect Initiative that's sponsoring this lecture. It's the university's commitment to developing across the road on the former Royal Women's Hospital site, Australia's premier innovation precinct. The first stage of Carlton Connect Initiative is now underway and open for business. Lab 14 on the corner of Swanson and Grattan Streets. You'll see the neon signs as you're passing. Now, back to tonight's lecture. As part of Carlton Connect's outreach, it established the Melbourne Dialogues on Innovation, Creativity and Entrepreneurship, or simply DICE lectures. And our very special guest tonight is Daniel Glaser. Dr. Daniel Glaser is a neuroscientist who has worked for many years promoting public engagement with science. He is Director of Science Gallery London at King's College London. This is a new space where art and science collide, to be constructed on the Guy's campus opposite the Shard in London Bridge. He was previously Head of Engaging Science at the Wellcome Trust, responsible for all external funding for public engagement in the arts. His scientific background involves the use of functional magnetic resonance imaging to examine how experience, prejudice and expectation alter the way we see the world. He comes from an unusual academic background, having studied maths and then English literature at Cambridge, doing a master's in cognitive science at Sussex University and graduate work in neurobiology at the Weizmann Institute in Israel and postdoctoral work at UCL. In 2002, he was appointed scientist in residence at the Institute of Contemporary Arts in London. This was the first appointment of its kind at an arts institution. In 2005, he was in the first cohort to receive a Cultural Leadership Award from the National Endowment for Science, Technology and the Arts. Daniel was also the first scientist to be a Man Booker judge in 2014. For this, I understand he had to read 156 books in 6 months. No mean feat, but the man for the job. Accordingly, it is my very great privilege to welcome Daniel to Melbourne and invite him to address us this evening on this most exciting topic of a beautiful mind, the brain and the creativity process. There will be time for question and answer following, and a hashtag for those tweeting is /DICE. Okay, Daniel, you have the floor.
Thank you very much. Thank you very much for that introduction, Karen, and I did kind of feel my life flashing before me as you read it, so you've heard most of the things I've done. It's really delightful to be here in Melbourne and to see so many familiar and new faces. A great pleasure to be here. I want to acknowledge, perhaps bizarrely for some of you, and I'll come back to this as we discuss things later, the city of Gold Coast, where I've spent a delightful 4 or 5 days just before I got here. I've got a visual gag later about that. But as you know, that the Commonwealth Games is coming to Gold Coast in 2018, and we had a really brilliant, world-leading, I would say, conference there over the weekend, looking at how culture and science and art in particular can come to a place like Gold Coast. And I understand, especially from the Melbourne perspective, that that might be a slightly strange idea. But then if you think about it, the benefits that culture and the conjunction between science and art and creativity can bring should not, I feel, my friends, be confined to the metropolitan elites, to the creme de la creme as represented here this evening, but can also be taken to places where culture is not ordinarily associated. And I would say that Science Gallery London is trying to do a similar thing, perhaps with less brashness than the Gold Coast, but still looking at people who would not normally be part of the story in terms of the control of science, scientific discourse, and the collision between science and art. So more of that later, but I do want to thank them for having me over. And I must say that the contrast between their approach to culture and that which I've experienced through the warm welcome I've had from the team here at Carlton Connect could not be greater. Still, culture is culture, and it's a delight to be here. On my way, I stopped off in Singapore. Some of you will have seen this fabulous edifice. Behind it is the Marina Bay Sands. If you've stayed there, put your hand up. Yeah, a few of you. It's all right, isn't it? These are 357-storey towers with the world's highest infinity pool on top. The engine that drives that entire development, which is on reclaimed land, is a massive casino. I'd never been to a casino before. I stepped into it, and it reminded me of nothing so much as a milking parlour. Lots of mammals connected to machines that were gradually emptying them of their worldly possessions. It's an extraordinary place, and I commend it to you for anthropological interest, if nothing else. And the reason I have the slide up is that you'll see on the bottom right the Art Science Museum, the world's first art science museum, not science gallery, but art science museum. And the reason it's there is quite interesting. The Singapore government, as you know, is strict in its control of everything, which is one of the nicest reasons why it's so nice to visit Singapore. And for them to grant a casino license to the Sands Group of Las Vegas, not an obvious cultural fit, they demanded a huge investment in culture. The architect of the whole development, Moshe Safdie, an Israeli currently based in America, conceived from the outset that at the heart of this cultural offer, which includes clearly shopping centres and a beautiful development by the bay, would be an art science museum. And I think it gives a testament to what I think is a relatively new sense that science and art, the conjunction between them, can be seen as the jewel in the crown of culture, perhaps in some respects, in urban planning terms, the highest accolade that you can give to an institution. So it's particularly delightful to see the developments that are happening in Melbourne University in that direction. If you're passing through Singapore, I commend the museum to you. Now look, clearly conjunctions between science and art are not new. They've been going for a while. Again, this slide I was delighted to have been inspired by my visit to Gold Coast in preparing, although I thought for a change it would be nice to see some naked male flesh for a change rather than the meter maids that parade up and down the front in Gold Coast. But having been inspired by my trip to that surfer's paradise, it did occur to me that maybe Leonardo, in his extraordinary studies of anatomy, which capture, I think, the highest aesthetic of the human form through his craft, but also study the body in motion, was potentially investigating a couple of moves which I'm told by my friends in Surfer's Paradise would be known as a Rio and also a Kari. If you don't know what either of those things are, then come and see me afterwards and I'll try and explain to you. But clearly the human body in motion is something which can be investigated in many contexts. I suppose the other thing that's interesting to me about the whole art science thing is that whenever it's covered in the media, there is this sort of, oh my God, scientists are talking to artists. There's, you know, that the hook for the media is this extraordinary and unprecedented conjunction, as if the two cultures had never met. But clearly, this has been going on for some time. And at the ICA, the Institute of Contemporary Arts, as Karen mentioned earlier, in 1968, a groundbreaking exhibition was mounted, which was called Cybernetic Serendipity. And in this show, for the first time, at least in London, and perhaps in the world, the outputs of computer programs, those are pieces of human endeavour that are produced through a machine rather than a paintbrush and a palette, were exhibited in an arts institution. And this gave rise to the first expression of computer art as a form. And the ICA, as the host of that, I think, showed its foresight in introducing an unusual conjunction and making a strong, almost moral point about the access of the geeks, as they weren't yet called in those days, to culture. Saying it's okay to label a picture drawn by a computer as art if it has aesthetic value, and that you can put it on the walls of an arts institution. So that was Cybernetic Serendipity, 1968. And the kinds of collisions between science and art, which we'll talk about later in terms of Science Gallery, were evident from the beginning. Here is a picture which may not shock Australians, but certainly was quite troubling in the UK in 1968. This is Princess Margaret talking to a man in a pair of trainers. This was not the kind of thing that happened in London in 1968. And certainly there were social conjunctions at the heart of the art-science collision, which we can celebrate. And once again, and I'll come back to this point later, it feels to me as if the space that's opened up when science and art collide is a space into which a lot of things can be fitted, including the radical notion that people from all kinds of backgrounds can be part of the creative process. Okay? Now, as Karen mentioned, I was the world's first scientist in residence at an arts institution, and that was in 2002. And I guess as a result of that, I've thought quite a lot about the connections between science and art. And I'm sorry to disappoint you, but I'm not going to give you a definition of either. But I do want to say a couple of things about the way that they are used in culture. Firstly, was that an art-science collaboration? I think the answer to that is yes. At the time, I was at UCL. And I was the imaging neuroscientist in the Institute of Cognitive Neuroscience. And so my job title had the word science in it at least twice. And that meant that I was a scientist by professional designation. And the Institute of Contemporary Arts had the word art in the title, right? So in fact, what I spent most of my time doing was hanging out in the bar. And at the time, the ICA bar in 2002 was the place where science and art collided, sometimes physically. And that was an important thing. And in a sense, also, the moves that we're making in Science Gallery are to generate these neutral spaces, these spaces where it's okay for anybody to say anything. And I'll talk more about that in detail a bit later. But I do think the place for these kinds of collisions is really important. Okay? Now, I'm an imaging neuroscientist. That means I look at the brain and what's going on in the brain. And my work originally was looking at perception, particularly visual perception, and asking how prejudice and expectation change the way we see the world. But I've also become quite interested in creativity and how we can generate spaces where creative encounters can happen. And I'll come back to that too. But I feel I should ground the discussion of the visual system in perhaps the earliest formal study of its origins. And that's not with Descartes or indeed Newton's optics, but back around about 1,000 years. A pint for anyone who can tell me who drew that picture? Well, Melbourne. So that's Ibn al-Haytham, who was the Arabic scholar of 1,000 years ago, roughly. And he was one of the earliest to inquire into the visual system. He also, and his collaborators, came up with a variation about several hundred years before of what's called Snell's law, which investigates the refractive index of different materials and how light bends when they go into it. And what Ibn al-Haytham has drawn for us here, as many of you will have seen, is a picture of what's called the optic chiasm. So the optic chiasm, my friends, is the way in which the nerves that come out the back of your eyeballs connect into the back of your head. I was in Lab 14 earlier talking to a brilliant bunch of schoolgirls from across Australia who are here for a Fab Lab, which is an innovative innovation, as we would expect. And we were talking about the optic decussation and how it's all joined up. I don't have time to take you through it in great detail, but suffice to say that the connection patterns between your two eyes and the back of your head result in a sort of back-to-front, upside-down picture of the world that's sort of projected back there. And Ibn al-Haytham, through dissection studies, had shown that it was there. But the question that Ibn al-Haytham was asking was the following one. And it's one which people have been discussing for ages, including Descartes and others in the Renaissance. 1,000 years ago, he asked the question, is seeing something which is done by things going into the eye or things coming out of the eye? He asked that question. Is seeing something that's done by things going into the eye or coming out of the eye? Now, that's not as silly a question as you might imagine. Clearly, touch is something which we put out into the world and feel it, and we sense the world through our fingertips and make an image of it that way. Maybe we have seeing rays that come out of our eyes that feel the world and sense it. And clearly, as some of you will be thinking, some of our mammalian cousins, the bats, and indeed dolphins, use a form of sonar to do that, and the radar principle works. Bats emit high-frequency sounds which bounce off the world, and the return tells them what's out there. So maybe seeing is like that. Ibn al-Haytham reasoned that that wasn't the case because he said, and please don't try this at home or outside, if you look at the sun, it hurts the back of your eye, and therefore there's something going into your eye causing that pain, and so the light goes in. And we know now from physics that in the case of vision, it's photons going into your eye which trigger a chemical cascade in the detectors at the back of your eye, which is transduced into electrical activity, and so it goes on up the visual system. So in that sense, seeing is about things going into your eyes and telling you about the world. But there are some confusing things if you look at the neurobiology, and particularly the neuroanatomy of the visual cortex. That's the bit of the brain which processes vision here at the back. And one of the principles of neuroanatomy is that if any two areas in the brain are interconnected, there are as many connections going one way as t'other. Right? So it's not the case, if you look at the connections in the brain, that information simply flows into our eyes, up the processing hierarchy, and pop, out the top comes what it is we're seeing. It's not that kind of bottom-up process. Rather, there's as much flowing out from our perceptions, our prejudices, our expectations of the world, flowing down towards the eyes as there is information flowing up. And to illustrate that better, I want to show you one of the most exciting findings in visual neuroscience of the last, well, I would say 5 years, certainly of the last year or so. And many of you will be familiar with it, but in an unusual context. So who has seen this picture before? And actually, I heard murmurs of acknowledgement and also actual groans already in response to that. This is the famous blue and black dress, and just for the fun of it, because I can't resist. If you see the dress as blue and black, put your hand up now. If you see the dress as gold and white, put your hand up now. Interestingly, in the southern hemisphere, there are more gold and whites than blue and blacks, which is unusual. And can I just say, if you've not come across this before, that the first time I saw it in the room with somebody who saw it differently, I had that funny feeling where until that point I thought I was sharing my room with a human, and it turned out they were actually an alien, right? I mean, it's very, very unsettling, this thing, and people do swear blind that it is the other colour, and they're clearly wrong right up until the point where it flips. It's very undermining. Now, let me tell you quickly what's going on with this. The first thing to say is that it was a genuine discovery of a woman who went to a dress shop in Scotland to buy a gown for a wedding she was attending. She took a picture of it. She sent it to her friend to ask what her friend thought, and her friend said, well, why would you be wanting to wear a white and gold dress to a wedding? And she said, a what? And her friend said, a white and gold dress. And so she put it up on the internet, and it kind of went viral. It was the most tweeted thing for about 2 days. And I know that the internet is mostly full of pictures of cats, but this is really a genuine new finding in visual neuroscience. And I can briefly explain to you how it works. But before I do that, I want to tell you that while we sort of knew the mechanisms that underlie this effect, no one had ever been able to construct an image with these properties before. And furthermore, since it's been discovered, right, and I say discovered because it really was not constructed, no one's been able to make another one. Right? So that's kind of interesting, sort of the most interesting thing to come off the internet for a while. Clearly, this is an example of a bistable visual phenomenon, and a couple of more classical examples of it are shown there. So the face or vase illusion on the right, you can flip that between a face and a vase. And let's look at the duck and rabbit on the left. I think almost all of us will have seen some form of this. So you can see a duck, you can see a rabbit. If you've never seen it before, just look at it for a while. It'll flip. For most people, it flips with a frequency of between 10 and 30 seconds. Is that what's happening to most of you? Yeah, flipping to a duck and a rabbit. If you want to flip it yourselves, you can do that by using your eyes to either look at the beak, and that turns it into a duck, or at the eye, and that turns it into a rabbit. And it's kind of fun if you flick your eyes between the two, you can flip the stimulus across, okay? I wouldn't say hours of fun, but, you know, certainly some minutes of fun with that, if you like. Now, just to be clear about back to Ibn and Haytham and is the vision thing going into your eyes or coming out of your eyes, clearly the photons that are going in, I don't want to get into too much detail here about eye movements, or we could come back to it, but the photons going in aren't changing, right? Roughly the visual stimulus is the same, but clearly what you see is different. And again, to the girls this afternoon, they said, yeah, but what about when you're just seeing? There is no just seeing. All seeing is a projection, a labeling, something that you're putting onto the world. There's no such thing as just seeing. All seeing is about mapping something which is already in your head to the stimulus that's coming in to the world. Now, the blue and black dress, white and gold dress thing has properties in common with that. So it's a single visual stimulus which has two different percepts. Things that are different about it, first of all, you can't really flip it by choice. Very few people can. There was one girl this afternoon who said she could, but it's very unusual. You can't flip it by choice. Secondly, the characteristic time of the flip. By the way, any of you here, if it flips for you during the display now, just let me know, because it's always really fun. Hey, good man, hey! All right. It generally happens pretty slowly, so it can happen on the period of hours. For most people, they kind of wake up in the morning thinking that their roommate was crazy. They look at it again and they're like, oh my God, it's flipped. So it's generally kind of overnight that it flips, and we don't know why that is either. There seems, in my experience, to be a mild gender bias, so more women see it as white and gold to begin with than men, but again, that's not consistent, and studies are ongoing. Do you want me to tell you how it works quickly? All right, so roughly speaking, let's think about this jacket for a minute. Okay, so this jacket is what colour? Jacket? Come on. This one, the one I'm wearing, my friends, is kind of bluey. So, but if I were to take a sunset walk by the Yarra River, okay, it would be illuminated by reddish-orange light from the sunset, but you would still see it as blue. Okay? Equally, if I were to stand under the house lights there, shall we do it? Bom. So now I'm standing under some very whitish light, so it's being illuminated by whitey bluey light, but you still see it as blue. Okay? So your perception of the colour of the jacket is pretty much fixed, but, and this is the critical point, so work with me, if I were to take a spectrometer, right, that's a device that measures the wavelengths of light coming off an object objectively, it's evident, isn't it, that when it's illuminated by red light, the light bouncing off it will be different than when it's illuminated by white light. Yes? Is that kind of clear? Objectively speaking. But we see it as the same. And that, my friends, is very clever, right? That's something which our brain does. Many other species don't do it. And I don't want to get into evolutionary speculation. So let me just say, I'm not claiming this is true, and I've no idea how I would prove it. But imagine that this evolved in the following context. You're a primate, you live in the forest, you like eating berries, some of them are poisonous, some of them aren't. It's quite important to really know what the colour of the berry you're about to eat is, no matter whether it's sunset or not, if it's buried in the undergrowth or high up in a tree. So colour constancy, this ability to infer the absorption properties of a material independent of the illuminant light. It flipped. Did it flip? Independent of the illuminant light is probably a useful thing, okay? Whether that's the reason it evolved or not, that's what's going on here. So, if the light that illuminates the dress in this picture were white, then it would be a blue and black dress. And again, I'm not trying to diss anybody, because everybody sees what they see, but in reality it is blue and black, right? If you were to go to Scotland and see the dress, it is blue and black. But do you notice that there's a kind of bluish fuzz in the top right and to some extent in the bottom left of the image? There's something there which, it's just a bit of a fuzz. And what happens, we think, is that your visual system sees that bluish fuzz, those of you that see white goals, say, oh, this is a picture that is being illuminated by bluish light. Look at it up there, that bluish fuzz. And if this dress, when illuminated by bluish light, looks as it does here, it must in reality be a white and gold dress. Okay? So your colour system corrects for an impression of the illuminant light and recovers a different colour for the dress. There you go. Does it still look blue and black and white and gold? Sure it does. That's because perception is automatic and introspection is useless, right? I mean, any sense of what's going on in our brains that we gain by introspection is completely illusory, and we tell ourselves stories about what we're seeing all the time. So, perception is driven by prejudice and expectation. What we know of the world, but whether through the construction of our brains and how they've evolved, or through what we expect to see. And again, back to Surfer's Paradise, when I looked at the waves, they looked, pretty or rough or something. To the inhabitants of Gold Coast, they see a rip that's moving to the left, they see a dangerous undercurrent, they say it's time to go and have another coffee, or it's time to reach for the board and head to the surf. The waves look different to them because of their experience. Okay? So in the neuroscience that I was doing at the time at UCL, I was interested to see how experience changed what you see. Okay, so not stuff you would have been evolved to see in the forest, but how your experience changed. And we were particularly interested in motion and the perception of motion. Myself, as you'll probably see in a second, I can't dance at all. But we thought that dance would be a clever way of looking at this. And fun enough, just for those of you in academia, we got some flack for that, interestingly. So when we published the paper, and I'll come back to that in a second, some of the reviewers said, well, it was very clever of them to use dance and kind of cool. But wouldn't it have been better for us to have come up with a stimulus in the lab as neuroscientists, trained some undergraduates in it, and tested them on it? And the answer is no, that would have been hideous, right? That would have been an awful thing to do. It would have been hard and terrible, and it wouldn't have got us the results. Because we were looking for people with real expertise in movement, both in seeing it and doing it. And the way we did the experiment was to take a pair of movement forms, and one is classical ballet, and the other is capoeira. Capoeira is a Brazilian martial art, or dance form, depending. It was developed by slaves in Brazil, and they weren't allowed to organize into fighting forms, and so they developed a form of fighting which, when they were doing it, if they were caught, they could say, no, we're just dancing. And also, because they were wearing uniforms, one of the basic rules of capoeira is that you can't touch the floor with your elbow or your knee or your arse. You can only touch it with your hands, your feet, and your head, and that means you don't get your uniform dirty when you're practicing. So capoeira is a fighting form, and it shares with classical ballet the following property, that you can say a few words in Brazilian, in Portuguese, and the practitioner will do a certain set of moves. You can see I can't dance. And likewise, in classical ballet, the same is true. So we generated a set of moves in capoeira and in ballet. We used a choreographer and a capoeirista to do it, and you can see here one of them. Roughly speaking, the capoeira move is kind of a step to the right, step to the left, and then a kind of rotating kick. And the ballet move is kind of step to the right, step to the left, and a sort of rotating kick. And kinematically, that means in terms of the body parts and how they move, they're roughly the same. When done by me, they both look horrible, but when done by experts, they are clearly identifiable as moves from within the form. We then put a bunch of capoeiristas and ballet dancers into the scanner. We looked at the activity in their brains, don't have time to tell you how, beyond saying it's fMRI, functional magnetic resonance imaging. It's a quantum technique that uses a very big magnet to spy on the oxygenation level of your brain and tell you where the activity is happening, where in the brain the activity is happening. And we asked the question, what is the difference between when you're seeing something you can do and when you're seeing something you can't do? Right? So for both groups of movement practitioners, there was a condition they could do, ballet seeing ballet, capoeira seeing capoeira, and one they couldn't, and we asked what's the difference between those two. Reasonable question? And we asked where in the brain those differences were. And the interesting finding was the following. When you're seeing the thing you can do, the bits of your brain that ordinarily control motion, and what do I mean by a bit of the brain that ordinarily controls motion? I mean a bit which if you lose it through an accident or a stroke, you're paralyzed, right? So its function is to control motion. Even when the subjects were still in the scanner, and you've got to lie pretty still not to blur the image, their movement control brain was more active when they saw the thing they could do than when they saw the thing they couldn't do. So even though they're not moving, they're using the bit of brain that controls movement to help them see the movement better. And that is a projection, it's a simulation that uses your experience to see the world differently. And it's even slightly worse than that. If you're a ballet dancer and you go to the ballet, it's generally a miserable experience. So it's not miserable, but it's certainly boring. You see it as an entirely technical exercise. And likewise, at the other end of the spectrum, if you've never ever seen dance before, let's say you go to Japan and see a traditional dance, it's also a cold experience. It seems that aesthetic pleasure comes from a sort of intermediate level of resonance, but we can come back to that with my final image at the end. Anyway, we showed how prejudice and expectation allowed you to see the world. Now, how did we manage to get the dance in? And that's the point of today's lecture, really. As I said, I was hanging out in the bar at the ICA, which is a great place to be. And a few people came to see me at that time. And one of them was Deborah Bull, who'd been a principal dancer at the Royal Ballet for many years, and actually is now Director of Culture at King's College London, where Science Gallery London is. And she gave us access to the Royal Ballet. And what we did, and I want you to understand the anatomy of this quite carefully, we paid a choreographer from the Royal Ballet to make us these stimuli. Okay? His name was Tom Sapsford. He's a brilliant choreographer. The work, I should say, was done with Julie Grays and Beatrice Calvo-Marino, Patrick Haggard, Dick Passingham at UCL. Now, Tom was interested in what we were doing, and we had lots of conversations about it, but it wasn't really a symmetrical collaboration. He wasn't making a dance work at the same time. He was just helping us to do science. And the outcome was a peer-reviewed science paper, a pair of them, which were highly cited. So let me tell you what I think is going on there, and I'll come back to this repeatedly in the talk. It's what I'm calling the convergent-divergent model of interdisciplinary collaboration. What I think is going on is that you need people from different disciplines. And like I said, I had the word science in my job title. Tom has the word choreographer, an arts domain. So we are coming from different places. And we can talk about it in questions if you want, but for my money, actually, an education which allows people to be a certain thing is a good education, right? You want to get an identity intellectually. So I'm in favour of that. I can handle a liberal arts curriculum a bit, but I do think you have to specialise at some point. So you have people who come from different places, and then you generate a space where anything's okay. So I call that the Dilation Frenzy. It's a sense, you could also call it the orgy model of interdisciplinary collaboration. You generate a space where you kind of lose track of who's doing what to whom, and it's all sort of allowed. And you need to sort of, you need to suspend the normal rules of engagement. And in that context, it's fine for the choreographer to say, I don't think that the stimulus should be that way in the scanner, I think it should be the other way around. Or we can say to the choreographer, don't you think that the arm is a little bit too bent? Shouldn't it be straight a bit? And that's kind of okay. That's not okay in general. We come from different places. But in this space, where creative approaches to problems can thrive, it's all allowed. And to the extent that this is a talk about creativity, it is a talk about that place where you lose track and the superego judgment of what it is you're supposed to be able to talk about, and rather find a space where it's okay for anybody to say anything. right? That space of a lack of self-consciousness, and we do have some brain imaging data to suggest where that takes place, but no brain imaging data to tell you how to do it. You need to be director of a thing like Science Gallery to pull that off. You create a space where these conjunctions happen, where the disruptions to how you would normally think happen, and this sort of creative frenzy takes place. Now, for my money, once again, having generated those interactions, you then re-describe them back in your home territory. So we went and published some science papers. They weren't published in a science art journal. I'm actually not that much in favour of science art journals. I think conventional measures are good. And Tom went back to his choreographic career. Now, biographically, he'd been in this experience, and for his next work, we might describe, that fact, but it wasn't key, and it wasn't what he was doing at the time, and he was paid as a consultant. Thought you might like to know where in the brain these things were happening. It's not really important. There, there, and there, and on the other side, there and there. This isn't a story about brain research, and those are the motor areas that I was describing. But these were published in a high-quality peer-reviewed journal and got the applause, the citations of our friends. Now, let me give you a mirror image story of a different kind, and this is through the work of the choreographer Wayne Mcgregor, that some of you will be familiar with. He's another person who came to see me in the ICA bar in 2002. By the way, I just want to say, since 2002, and the ICA bar was good till about 2007-8, Wellcome Collection, which if you visit London I encourage you to look at, became the place where art and science collide in London. To the extent that if you're having a coffee there and you want to start a collaboration, the person that you want to work with is almost certainly having a coffee on another table somewhere else. And for me, in 3 years' time when you come to London, you will find the Science Gallery London Cafe to be the place where art and science collide. And I mean, I am ambitious. We want to take over the mental. And this is a still image from the publicity work around the piece called Ataxia by Wayne Mcgregor. Wayne is the resident choreographer at the Royal Ballet, and I think Britain's finest choreographer living. And let me tell you how he did ataxia. So ataxia is a medical term for a kind of movement disorder. And what Wayne did was to take his dancers into the lab of a woman called Ros McCarthy in Cambridge, and she's a psychologist, and they played around with some distraction tasks. Now, distraction tasks are interesting. If you count backwards from 100 in ones, 199, 98, 97, 96, 95, 94, you can kind of carry on walking at the same speed. It doesn't interfere with your movements, and you can do complex tapping tasks and so on. But if you count back in 13s from 100, I'm not even going to try that in front of you, it can disrupt your movements a lot. And there are some distraction tasks of a mental nature, things that you do in your head, which can really get you to lose control of your body. Okay? And that's kind of exciting. And what Wayne did was to do that to his dancers in the psychology lab. They have a sort of studio attached. And he used those movement patterns that were generated to construct a new movement vocabulary, a palette with which he painted. And using those images, and I'll show you a few low-res shots now, he made a new language of dance for the piece Ataxia. And the movements that this generated were performed at Sadler's Wells. And the sort of, and I apologize for the low resolution of these images. The beauty of these kinds of performance was the following, that by the end, at a certain point, one of the dancers took his arm, even I can do this, and moved it out like that, and it was as if you'd seen that art movement for the first time in your life. Your visual system over the hour had recalibrated itself to this distorted kind of movement, and genuine, natural, as one might say, movement, undisturbed, appeared afresh for the first time. So he really messed with our visual systems and produced an extraordinary piece of dance. Now, there was Dilation Frenzy in the psychology lab, so that's okay, and the people doing the story had come from the two different backgrounds. The outcomes of this, as far as I know, Ros McCarthy didn't write it up for any kind of science paper, because there wasn't really any new science there. We all know about distraction and what it can do to movement. And Ataxia went on at Sadler's Wells, which is the premier experimental dance venue in London, and was reviewed by the dance critics of the major national papers and some of the bloggers. And that's how you knew it was dance, and that it was good dance. It wasn't a piece of sci-art. It wasn't good because he'd done all this interesting work with a psychologist. That was in the program notes, and that's fine. Before the thing started, the interval, if you take it home, you can read about it. But for my money, that is as interesting as who he was sleeping with, the dance tradition from which he came, where his money came from, which city he made it in. It's all interesting, it's all biographical, it's all background, it's an enhancement to one's experience of the piece, but it's not at the heart of it. What he'd made was a piece of dance, and it was seen in its own terms. So once again, it feels to me as if what we should be looking for in trying to find new creative ways of making work are spaces where different activities can be shown to work together, but the outcomes go back into an original form. So, Science Gallery London, what's that all about? It's a space where art and science collide. I think by now you know what I mean by that. It happens in the Guy's campus of King's College London, which is right by the Shard. Some of you will have seen this very big building in London Bridge. And the site for it is this extraordinary junction. I was really pleased with myself for having not said this on ABC this morning, because I think it would have set hairs running. But we also have a McDonald's in a hospital here. I understand you've just built a new one in the Children's Hospital. Congratulations. But Europe's first McDonald's in a healthcare campus opened in 1992 at Guy's Hospital. My mother was a consultant senior doctor at Guy's at the time, and I still, you know when your mum gets really angry, you really kind of remember it. So I just remember her visceral rage at the idea that a McDonald's had opened in the hospital where she was working. And it was on a 20-year lease, and when the lease was up, King's made the decision to open that space up as an interface to the world. Now that's an interesting thing to do, because normally and traditionally, universities are clad in ivory, the ivory towers. And what are the properties of ivory as a material? Well, it's impervious. It's good for the white keys of pianos because it doesn't get stained by your fingertips. And that was okay for the cladding of universities for a while. But nowadays, my friends, it feels to us as if universities need to face outwards. They need to open themselves to the city where they are, and they need to have boundaries which are partially permeable. So Science Gallery allows creativity into the university. So, for example, in our pre-opening season called Frequencies that we ran last year, this is a student midwife collaborating with a man playing a saw. Guess what the name of his band is? Sawchestra, sorry. And you take the saw, you hold it between your knees, you bend it, and you play it with a cello bow. And they made a piece of music which captured the rhythms of her day as a student midwife. And this was performed in a pop-up space underneath McDonald's. The gallery itself is going to open in 2017. And this is Sawchestra at work. And we also saw, and this is most of you saw as you came in the play-in, we worked with an artist called Bishi, who I think is fabulous. I hope you think so too, having seen her work. She worked with a pediatric sleep physiologist. That's somebody who puts children who can't sleep in the lab and measures their brain waves. And Bishi stayed up all night, came into the lab, fell asleep, had her sleep waves digitized, and that signal from her sleep waves was turned into a piece of music which you saw her performing at the play-in. This was performed in Guy's Chapel. That's one of my favourite images ever. And Bishi is the Eric Clapton of the sitar. So she takes the sitar and plays it through guitar pedals. What did we do in this context then? We made spaces where scientists and artists could collaborate, and we mixed up the boundaries. So in this image from the same season, can you spot the neuroscientist? I don't think you can. It's a woman at the back. She's a neuroscience undergraduate, and she was investigating with a bunch of kids from South London a thing called an earworm. An earworm is a tune that you get into your head that you can't get out. Very annoying. It's a direct translation from the German. And they constructed the tunes with the help of Jimmy Logic, who's a DJ, and then experimented to see which ones stuck and which ones didn't. So these conjunctions are taking place in Science Gallery, and we're involving people from all kinds of communities in South London. But there's one more clever trick I want to tell you, and then I'll stop. We invented a thing called the media team, and here are two of them. These are Grace and Amelia Mandeville. They're two sisters, aged 15 and 17, from South London. And they, along with some others from South London, document everything we do at Science Gallery. So we've turned over control of the documentation of the Science Gallery workshops to the audience that we're interested in, because Science Gallery focuses on 15 to 25-year-olds. And rather than hiring a PR agency, we worked with early-stage filmmakers, bloggers, and photographers from the communities we're interested in, and we turned over control of the documentation to them. So the collaborations of Frequencies, which were with borough market traders, hospital porters, the student midwife, as I said, the pediatric sleep physiologist, were digitized and filmed by them, and then cut and edited. Grace and Amelia have got 30,000 subscribers to their YouTube channel, my friends. And most of their films are the kinds of things you'd expect them to be covering: boy bands, mispronouncing lipstick brands and different kinds of shoes. But when you hand creative control of the documentation of Science Gallery to people like that, this is what you see. I probably should have warned you that the tune that we were playing there was one of the earworms, so I'm afraid that's with you for the rest of the evening, if not beyond. So that's what happens when you turn over creative control of a project like this to the audience. 15 to 25-year-olds have the most extraordinary creativity, and they know how to tell stories in a visual language and a vernacular which makes sense to their peers. So I think that the lesson there is clear, that without jeopardy and without actually giving up creative control, you can't create anything exciting. But in Science Gallery London, and this is an image of what it's going to look like, we plan to do exactly that. I don't have time to give you a full walk around, but we'll have 3 floors, including a retractable seat theatre, galleries, cafe and shop. This is what it will look like from the Shard. And we also have a lovely Georgian courtyard, which is currently the consultant's car park. Again, in the pub afterwards, asked me what it's like to close down the consultant's car park if you want to make friends in the hospital. It's not pretty. And this is the famous cafe where we will be hosting the most exciting art-science collaborations. Our next season is called Fed Up, which is about the future of food. Here's a graphic for it. It launches next week, and we're interested in different forms of protein and how they can fit together. And here are 2 young men from Peckham, who I call the Peckham Prophets, because their names are Jeremiah and Samuel. And we've been paying them to come into Borough Market, the food market, and make some film about fermentation and to tell their viewers and their followers in their radio station what that looks like to them. So in summary, my friends, in order to get creative, you've got to bring things together that only exist normally in tension. You've got to create safe spaces where it's okay to take risks and where everybody's view can be heard. This is true public engagement. It's not about a lecture from an expert to an audience, pleasurable as I'm sure that is this evening, but it's about spaces where scientific authority can be challenged, where the audience set the agenda, and where that happens, true creativity takes place. Thank you very much for your attention.
Thank you, Daniel. I think we'll take some questions. We might ask you to come up here. Any questions from the audience for Daniel?
I think there may be a microphone coming to you, sir. Oh, this is loud now, isn't it? There we go.
What about the use, the loss of motor control with the obsessive use of mobile phones while walking along?
Yeah, that can be dangerous, definitely. I mean, it's worse. I mean, the heavier the object you're in control of, the worse it is to be on the phone. As a cyclist, I have great fun in London photographing the drivers of large vehicles as they use them. I guess what I'll take from your question is the following. There is a lot of anxiety about especially the younger generation and the effect of mobile and other technologies on them, the distraction which that embodies and the fact that they can't get anything done because they're always on social media. And I take the conclusion of this anxiety to be the precise reverse of what is generally supposed. So first of all, we've got no evidence at all from systematic studies of any damage to young people's brains or changes in their pattern of education or concentration as a result of this technology. And I think the reverse is happening. When I was a young man, I was rubbish at concentrating at things. I could be distracted by, trying the pencil sharpener in the other direction. That was kind of the high spot of the interest for me. The fact that young people are doing well at school, and they still are, means that they've become real experts at juggling the direction of attention and fielding the massive set of inputs coming to them. So rather than lamenting their distractibility and their inability to concentrate, I think we should celebrate them as masters of navigating the sea of distractions in which they find themselves. And therefore, I am very optimistic about the role of technology in the development of the young today. But yeah, that's a partial answer to your question.
What benefits have we got in... Oh, sorry.
One over there? Okay.
Hello.
Hello.
Have you struck any benefits in improving scientific thought and method by running around with chaotic artists? And is there ways we can sort of hack our way through the horrible formality of science, which might actually be, framing the way we see the world?
Yeah, it's a good question. The first thing that happened was that we checked it wasn't doing any damage. So there was a study about 10 years ago from Anselm, the French funder of science, which addressed the proposition, as many scientists imagined, that doing public engagement damaged your career. And they found no evidence for that. There's no reduction in the rate of publication, highly cited papers, or grant income. So no, it doesn't damage you. And there's actually increasing evidence to suggest that engaging with a bunch of people who are not experts in your domain makes for better research. That's partly because you have to justify, explain to a bright 9-year-old what you're up to every few years is probably a good idea, even if you're a theoretical physicist. And the kinds of collaborations that you can come up with from these things definitely do move science forward. I should say as well, I mean, it's coming to Australia as also, researchers are now bound to do that. It's part of the research funding in general that you have to engage the public with what you do. Rightly so, in my view. It's a democratic deficit if you don't. But like it or not, it's now a part of everyday science. But you should like it because it will make your research better, in my view.
It's been great fun listening to you tonight. What I was wondering is, it's wonderful to involve scientists and those non-scientists in creative projects. Ultimately, what are you hoping the public benefit of this would be? What is the big picture for this?
Well, I think for me, the basic project here is about social justice, as I may have suggested at the beginning. So it is, I mean, just to give a quick example, in the UK, about 10 years ago, we switched from paid admission to free admission to the national museums. And the number of visitors to the museums doubled, but the demographic profile stayed exactly the same. So the people who weren't coming to museums still continue not to come to museums even if they were free. And that doesn't feel to me to be okay, right? I mean, it's iniquitous, but it's also stupid for the nation, because what you're doing, rather as a lot of tech structures exclude women from senior roles in tech companies, you're kind of, you know, I'm a feminist because it's wasteful not to be, right? You want to build things where everybody has a shot at it, because your nation will do better and the world will do better if you can open the military-industrial complex, the vast resources at universities' disposal to the widest possible range of people. So it's a good idea for the country to do it. It's also democratically quite sensible, and it's also just. And there are plenty of people, even in this illustrious city, who do not have access to the kinds of culture that I've shown you this evening. And one of the exciting things that Carlton Connect can do is to look at the districts in the immediate vicinity, at indigenous populations, immigrants, refugees, and people from various backgrounds, and offer the riches of scientific inquiry, the riches of art, and the riches of that conjunction to the full range of people. So Science Gallery is a space where that should happen, and art-science collaboration is a way of loosening things up a little bit to let other voices speak.
We have some questions at the front here.
You were using the analogy of ivory being impermeable, and the way that, you know, the university is the ivory tower, but you also wanted to have some interaction with the community, so something that was going on there. But then earlier you were talking about how then once that process has gone on, people should go back and use what they've taken and produce something within the domain where they originated from. So would you see you would want to do something where you would still have the, I don't know, ivory tower as a core, and then around that you would have areas for interaction where that would go on?
I love your architectural vision, sir. It sounds very beautiful, the city. I have a slightly simpler model, but thank you for the paraphrase. I think you've captured it well. For me, the material that so I'm not against interdisciplinary boundaries, right? I think there need to be membranes between things. The membranes need to be selectively permeable. So to take a biological metaphor, membranes keep some stuff out of cells and let other stuff in. They've got passive channels to let certain things through, gatekeepers, and they've got active channels which funnel, which pump things into the insides of cells and pump things out. And I think of the university boundaries as a membrane that's selectively, and I won't say intelligently permeable, and so there is a differentiation between inside and out. I mean, how do you get rid of membranes? Detergent's good for that. Washing up, you get mush. So no, we need boundaries, we need membranes, they just need to be smarter. Thank you.
Thank you. Thank you very much for tonight. Fascinating. I wonder if you've had any or undertaken any collaborations with non-scientific communities to do with creativity in terms of musical expression, and what, if any, functional MRIs have been conducted in that area?
Yeah, I mean, the answer on that is tons. It's not something I've done. Well, I've done a bit on it. But yeah, music's super interesting because you've got all these mappings between eyes and ears and hands and memory and all sorts. And also it's a thing where there are lots of different traditions and creativity. So yes, it's something which is super interesting. Like all good things these days, you can find out about it on Wikipedia. I do a lot of science communication. I remember being on Drive Time radio in UK a few times talking about quantum teleportation. And right, well, so I'm a neuroscientist, so I know nothing about about it. And so I explained it to them. But before I explained it on the radio, I said, and I just want to make it clear that I did look this up on Wikipedia half an hour ago like everybody else, right? So I am good at explaining stuff because I've had a scientific career. But I think it's important to demystify this idea of the inviolable truth of scientific inquiry. You can explore the question that you just asked by, through Wikipedia, work of Lawrence Stewart and others. But yeah, there's tons of stuff out there, brainfacts.org. I mean, there's plenty of places. This is an amazing time, folks, to explore this kind of territory. Yeah, there's tons of stuff on music. It's a good question.
Daniel, maybe if I could come
Please.
in. In part, the way we're teaching students at school is in silos, all the disciplines, and then we can bring them to university and reinforce that. So, to me, what you're trying to do is take them into spaces and show them creativity. And I think school doesn't necessarily reinforce creativity, and I think this kind of process, to me, is well able to do that. I wonder if you could just comment on what you think schools are doing in the space of creativity.
Yeah, I mean, among many things, it's a good thing I'm not, perhaps it's a teacher and certainly not an education policy maker. Because I'm a little bit conflicted about this. I really do think that it's good to specialise. And I also kind of think, I mean, the title of today's talk, many of you will know, a reference to the fabulous mathematician, the guy who got the shortest recommendation ever when he was recommended to Harvard. His recommendation was just written, he is a mathematical genius. As you may have known, he died very recently. A friend of mine was in Oslo to present him with the Abel Prize, and he died in a car crash on the New Jersey Turnpike on the way back from the airport, having flown from the ceremony, which is a huge tragedy, 86 and a complex life, but richly lived. Mathematics is a kind of thing which, if you can do it, you should. I remember hearing some parents of a 17-year-old girl asking me for career advice, and they said she doesn't know what to study at university. She's trying to decide between maths and... I said, stop right there. If maths is one of the choices, you should do it, because nobody ever starts with French literature and moves to maths, right? So I do think that if you can do maths and computationally hard subjects, if it floats your boat, it's something you should probably focus on. I think becoming deeply and clearly good at a particular thing is something which school and university can teach us. But we must not be illiterate savages, and we must, by which I mean we must respect other discourses, Pache, Richard Dawkins. We must understand the value of the humanities, even if we are great scientists ourselves. And so we need to learn respect, and we need to learn the skills that enable us to understand other people's discourses as well. But I don't think there's anything wrong with depth and specialization per se.